Delay. Ran a little bit late on the first one. Thanks for coming to our conference. Hopefully you're getting settled in. You're ready to learn a whole bunch of new stuff here in the next couple of days and get really excited about creating applications for Windows Mobile. My name is Scott Skorupa, and I'm the Director of Development for the Mobile Devices Product Group. And I'm going to talk to you about native code development on the smartphone today. And as Director of Development, I'm responsible for all of the developers who actually write code for the shell and applications such as Pocket Outlook and Pocket Internet Explorer on the Windows Mobile platform, which includes both Pocket PC and smartphone. I'd like to start by talking about the marketplace a little bit. Mobile device adoption continues to grow. Our analysts predict that by the year 2007, there'll be over 500 million devices available out there. And a large portion of these are going to be Windows Mobile basis devices. And of particular interest to this group, of course, is the smartphone. We continue to work with more and more OEMs to get a broader range of devices out there. And we're engaging with more mobile operators to get a broader deployment to users. This momentum is a huge opportunity for the ISV to create their applications. Mobile operators are looking for more and more applications as well. They're finding that our Windows Mobile-based devices are increasing their average revenue per unit by $25 a month. On top of this, Microsoft is seeing a huge increase in the number of applications being written. Over 700 new applications have been added to our mobile devices catalog in the last year. This is a block diagram of what the Windows Mobile platform looks like today. At the very bottom is the hardware abstracted away from the system through a series of drivers, just like you have on the desktop. It means as mobile application developers, you can concentrate on creating your applications, not worrying about the variety of hardware out there. The Windows Mobile platform is based on Windows CE. It provides a familiar user interface and applications that are familiar to the user, such as Pocket Outlook and Pocket Internet Explorer. All of this is tied together with a set of tools that I'm going to go into detail here in a little bit. This is a roadmap of Windows Mobile from where it's been here in the last couple of years and where we're going in the future. Smartphone we originally released in 2002. In 2003, we updated the software. It included some end-user improvements. A really visible thing is we added menu numbering to the menus, so users can quickly jump to a menu item by just pressing the number on the keypad. As developers, we built in managed code, so the .NET Compact Framework is built into the ROM. And then just today, we announced Windows Mobile 2003 Second Edition. And for the smartphone crowd, that means we're going to have some quarter VGA devices. So there's going to be a broader spectrum of devices for you to target as a developer going forward. This is a block diagram of what the Windows Mobile platform is going to look like in the future. The items in orange are technologies that we're going to invest in. They include things such as Pocket Watson, location support, and we'll even include SQL CE in the ROM. So for those of you who are Pocket PC developers, you've had to do RAM install of that in the past. So all of the tools are going to be unified in Visual Studio 2005, which is a project formerly known as Visual Studio Whidbey, and we saw some demos of that today in Bill's keynote. My talk today, I'm going to go into an overview of what the user model is on the device. I'm going to dig into the application security model, which is critical to the deployment of your applications, so it's very important that you understand that. I'll briefly discuss the tools to get you up and running so you can start creating your applications. Not as much depth as Paul's talk just was, of course. And then I'm going to write some code. We're going to dig into some specific areas. I'm going to focus on some native development. That's the topic of my talk. We're going to extend some menus to inside of contacts. We're going to use POOM to interact with contact items. And we're even going to dig down and do some radio stuff. We're going to send some SMS messages, and we're going to receive some SMS messages. Now this is a smartphone, a picture of a smartphone, and I've labeled some of the more interesting buttons on it. The items listed in black are things that the user are going to be using fairly frequently, but aren't really that interesting to most applications. The items I've labeled in red are a little bit more interesting to you writing your apps. The home key is used by the user to return to the home screen at any point in time so that they can dial the phone. So dialing the phone is one key press away at any point. The back key is a context-sensitive key that does what the user expects it to do based on where they are in the UI. For instance, if they're in an edit control typing in text, pressing the back key will backspace. If they are browsing in the Pocket Internet Explorer, hitting the back key will go to the previous web page, like the back function in the browser. The soft keys are used to interact with the menus for the applications. And then another key that I did not call out here, which I probably should have, is the round button in between the soft keys is a 5-way navigational key that the user can use to change focus and select items within applications. Now, when we were creating the smartphone, we had an overarching principle that we used when making our decisions, and that was you need to be able to operate the device one-handed without looking at the screen. So this gave us a bunch of ideas, or we designed our UI around this. Most of our applications are list-based. It's much easier for the user to keep track of where they are in a list and navigate two-dimensionally. Another ramification of this is smartphone devices do not have touch screens. It takes two hands to operate a touch screen, one to hold the stylus and one to hold the device. Another UI concept that we added was soft keys. The left soft key is an immediate action that does what the user most likely would want to do at any given point in time. The right soft key pops up a menu that has all of the choices for your application. Now, deciding what the most immediate action is to put on that left soft key can be a bit contentious sometimes. For instance, when we were creating the inbox application, which I have here on the screen for smartphone, there was a great debate over what we should have as the left soft key. Many people, including myself, thought it should be delete because 99% of the time you're getting spam anyways and you just want to delete it. Our user experience group thought it was a bad idea to put a destructive item on that immediate access key, and ultimately they won, and it's the new button. So, for the actual application model, we tried to break our applications down into 3 views to efficiently use the screen: the main view, the summary view, and the edit view. The main view is a list of items with just enough information for the user to make the decision of what they want to do with the item most of the time. There's just enough detail there. So for instance, in contacts, we have the person's name and then a hint. That letter is a hint as to what operation is going to occur should the user hit the talk button. So for instance, my name is highlighted there. If you hit the talk button, it's going to dial my work phone number. If the user wants more information than this, they drill in to a deeper level called summary view. Summary view contains all of the details about a particular item, but is formatted in such a fashion that it fits on the screen nicely. Should the user finally want to go edit something, we bring up yet another view, which is called edit view, and the user will very rarely go here. And it doesn't use the screen real estate quite as efficiently, but things are labeled so they know what they're looking at. All of the fields for an item are included there. So for instance, in the contacts example here, I don't have a mobile phone number listed in my contact, but it shows up in the edit view, so the user can add that for me. Obviously, this doesn't work for all applications. It wouldn't make sense to write a game this way, of course. But if your applications would fit into this model, I'd highly recommend it because it works quite well. So going from the UI, I'm now going to talk about the application security model. It is extremely important for you to understand the application security model because the ultimate deployment of your applications depends on this. It can be perceived as a bit complex. I'm only going to go into it briefly today, but hopefully it'll be enough to show you that it really isn't that hard. And then I'm also going to point you to a couple of extra resources here. The first of which is there is a presentation on Friday at 2 o'clock that covers nothing but this topic. Another great resource is there's a white paper up on the MSDN library that you can reference. And I've included a URL to this in my appendix slide for you to reference later. The point of the application security model is to protect the integrity of the device and the operator's network. It will help prevent viruses from spreading. It will help prevent malicious applications from running up users' phone bills. It's accomplished through doing digital code signing to validate the origin of the content that's about to be executed. And a thing to note here is this shouldn't be confused with the Design for Windows Mobile logo certification. That is a separate process from this. Now, the basis of the application security model is that there are 3 execution modes that your application can possibly be running in: privileged, unprivileged, and untrusted. An application running at privileged mode has full access to the system. It basically can do whatever it wants. An unprivileged application has the access to the vast majority of the system. You can do pretty much anything you want, except for you won't have direct access to the radio. You'll have to call through other APIs to make calls. And it's generally used to protect the system. Untrusted is yet another level where an application may not even be allowed to run on the system. An interesting thing to note is that if you're writing a DLL that is loading into another process and you don't necessarily have control over that process, your DLL needs to be capable of running in the same execution mode as the process it's being loaded into. And as you'll see later on in my talk, that's a very important thing to remember. Now, the mode in which your application runs is determined by the policy that's set on the device. And there are 3 sets of policies that we have for the smartphone: unrestricted, standard, and restricted. The unrestricted policy, your application doesn't need to be signed to run in any mode. You basically can put whatever application you want on the device, and it'll just work. The standard policy, if you want to run as a privileged application, your application must be signed. To run as unprivileged, things have changed between Smartphone 2002 and Smartphone 2003. In Smartphone 2002, you could just not be signed and you would execute just fine. In Smartphone 2003, we've introduced the concept of prompt mode. Prompt mode will prompt the user when your unsigned application is about to execute and ask them if it's okay. If the user says, sure, we'll run this application, then your app is allowed to run. If the user says no, then you'll be denied. The person setting the policy can turn off prompt mode in Smartphone 2003. And if they decide to do that, then you must be signed in order to run as unprivileged as well. Now, restricted is the most strict of the policies, and you need to be signed to run in any mode. The vast majority of the time, the mobile operator is the one who owns the policy. Most smartphones are sold through the operator. However, there are a few cases where the OEMs will sell devices directly to users. And in those cases, the OEM is responsible for setting up the policy on the device. So now I'm going to talk about tools, and I'm going to start off by talking about Smartphone 2002. The reason I'm going to start by talking about Smartphone 2002 is that is the only platform that is available in the US today. You can get Smartphone 2003 in Europe, and you should be able to get it soon in the US. But right now, all you can get is Smartphone 2002. So if you want to deploy things soon, we need to understand how to write applications. Smartphone 2002 only supports native code development. You need embedded Visual C++ 3.0. And that is used to compile and debug your applications. You'll also need the Smartphone 2002 SDK, which will include things like the header files, the libraries, and the emulator. In Smartphone 2003, we add the option for developing managed code. To do that, you'll use Visual Studio 2003. If you want to develop using native code, then you'll need embedded Visual C++ 4.0 with Service Pack 3 and the Smartphone 2003 SDK. Now, the tool sets include tools that you can use to manipulate the device remotely. Some interesting things that are there are a remote process viewer, a remote registry viewer, a remote file explorer. And all of the native code tools are included in the conference DVD that you should have received at this point. In the future, our development tools will be unified with Visual Studio 2005. It's a single environment for doing both managed and native code. It contains all the same great remote tools we have today. There'll be greatly improved ease of installation and much, much more. And then to just demonstrate how much easier it's going to be to install the tools, I'll first give you an idea of what it takes to set up developing Windows Mobile stuff today. Now, to give you a little context, setting up everything in this list will allow you to set up, develop applications for both smartphone and Pocket PC. But it's a lot of stuff. There's 12 different things there. There's 4 development environments to install. There's 4 different SDKs to install. There's an SDK update so that you get the emulator images for Windows Mobile 2003 second edition. This next slide shows all you're going to have to do once Visual Studio 2005 is released. So all of that has gone down to a single dev environment and 2 SDKs, which will make things much easier. So what I'd like to do now is walk you through a quick demo of the current tool set. What I have here is Embedded Visual C++ 4.0. I'm going to walk through the application wizard to create a simple Hello World application, which is pretty simple. And then I'm going to show you the remote process viewer. So I'm going to start off by bringing up the new application dialog. And in this dialog, I'm going to select a smartphone 2003 application. And I'm going to set the project name to MDC demo. And I'm going to confirm that, yes, I want a Hello World application. And then one final confirmation. And we'll grunt for a second there. And that's all it took. What I'll do now is we'll launch the debugger, and it is going to ask me to compile this. While this is compiling in the background, I'll bring up the emulator, which I already have running. So we're done compiling in the background, and we're copying the file over to the emulator, which you can see has a nice skin. It looks like a smartphone and has all of those great buttons I showed you earlier. Eventually, it's going to flip over to the debugger, and up comes our Hello World application, which was pretty easy to make. And I can hit OK to close this. Now, the emulator contains a full device image. So there's applications, all the applications are there, such as the Contacts app. I'll go ahead and show this to you here, and we'll create a new contact. And what I'm going to do is we're going to switch back to the environment, and I'm going to bring up the remote process viewer. I'm going to tell it to connect to the emulator. And we'll get a list of all of the processes on the device. I'm going to bring the emulator back up front here for a second. Now, an interesting thing about Contacts is we don't have an actual Contacts executable on the device. It's a DLL that gets loaded into a host process called appman.exe. So I'm going to go through this list here and find appman.exe. And the interesting thing is there are a couple different things that get loaded into appman.exe. So we have to look at the window name to determine the right thing. So here it's talking, the window name is start. This is for the home page. We're going to skip over that one. And here's the one for Contacts. Once we found the item we want to kill, I'm going to kill it in this case. We hit the big red X. We wait a second. If you watch the emulator, Contacts will disappear, and we'll refresh our processes, and we're done. And we'll shut all that down and switch back. So now we'll talk about getting into writing some real code. I'm not going to write another boring Hello World example because you can do that with the press of a button, as I just showed. The sample I'm going to show you today is to send an SMS, send a contact from one device to another using SMS. To do this, I'm going to be going into how to create menu extensions. We're going to be talking about manipulating PIM data using the Pocket Outlook object model. I'm going to talk about how to send an SMS message, and then how to intercept an SMS message on a device and then do some processing with it. Now, menu extensibility was added to smartphone originally in the 2003 release of the platform. It's a little bit difficult to find in the SDK help file. If you simply search for context menu extension, the right topics will come up and you can dig in. I'm also going to be working on a white paper that we'll be posting up on the MSDN library. And as I said before, I'll have a link in an appendix slide at the end of my presentation pointing to the MSDN library. And that should be available later on this spring. For debugging, you're going to find the remote registry viewer pretty useful to make sure that you're registered correctly as a menu extension. You're going to use the remote process viewer that we just looked at, and I've added again that contacts is loaded into appman.exe. The reason you'll be using the remote process viewer is you need to restart the application in order for your menu extension to load while you're debugging. There's no way for an end user to shut down applications through the UI. Smartphone uses an auto-close model. When the device gets low on memory, the shell actually will automatically close the applications down. So you'll have to use the remote process viewer to force the applications closed. You'll also have to do a little bit of creative debugging with menu extensions. The tool set requires a compiled version of the process that you're debugging to be located on the desktop machine. Unfortunately, we didn't ship the PIM executables with the SDKs, so we don't have that to attach. So you'll have to use creative things such as MessageBox and that kind of stuff. When I'm done with my white paper and it actually gets posted up on the web, I'm going to make sure the executables for contacts, calendar, tasks are all included in that so that you can actually set breakpoints and step through the code. The applications that support menu extensions today on smartphone are contacts, calendar, tasks, ActiveSync. They all support menu extensions from the main view. Calendar also supports it from the summary card. We're looking to expand this list as we move forward in the future, of course. Now, when we're talking about the application security model, I said DLLs have to be capable of running in the same execution mode as the calling process. Well, all of our applications in Flash are run as privileged by default. So therefore, all menu extensions have to be capable of as running as privileged. Now, in the future, we're looking at changing some of this, but hopefully we'll get there soon. A menu extension is simply a COM object with some extra information in the registry that will inform the host application that this object is something that is interested in being a menu extension. The things you need to know in order to register are the application you'd like to extend, obviously, and the documentation refers to this as the context. A second piece of information you need to know when registering is the class. The class is used to determine which of the menus you wish to extend. So for instance, in the previous slide, I noted that calendar has two different menus. The class is where you would differentiate between these. There are two interfaces you need to implement in your object. iObject with site and iContext menu. iObject with site is used as a simple citing mechanism to communicate between the menu extension and the host process. You use this to get your data back and forth, essentially. iContext menu is an interface with methods that center around manipulating the menu itself. So you're allowed to, or it's used to add your menu items to the menu, to validate your menu items, and actually invoke your menu item once the user selects it. A rough flow that happens here is there's a method called setSite that gets called in your menu extension, and in this, the host object passes you a pointer back to it. And that's followed by a call to query context menu, where you will add menu items, and you can add multiple items at that point. And that's all that happens until the user actually selects your menu item. Once the user selects your menu item, get command string is called to get a canonical string form of your menu command, and then that is passed to invoke command, where you actually execute your menu item. So at this point, I'm going to switch over to the editor, and I'm going to walk through some of this code. What I have highlighted here is the setSite implementation I was just talking about. It's a pretty straightforward function. you get passed in an IUnknown pointer that points back to the host process. We take it, we check to see if we had previously been communicated an IUnknown pointer that we saved, and we release it if we had. We save that IUnknown pointer, we add ref it so that our reference count is kept up, and that's all we do here. After this, query context menu is called. Let's do a search. Highlight this. Again, another pretty straightforward function. The parameters that are passed that are interesting are there's an H menu that you're actually going to modify to add your menu items. There's a range of command IDs that you can use. In my sample here, the first thing I do is I store the first command ID that's available in my back pocket so I can reference it later. Simply use the Win32 function insert menu to insert our menu item. Here we're going to be sending a contact using SMS, so I put the string to be sent using SMS. And then we set up a return value for this function. Now the interesting thing about this return value is it's not a standard H result. It's an H result that you build based on how you implemented your function. It's a success code where the code field in the H result is set to the number of menu items you've actually added in your implementation here. In this case, we've only added one menu item, so I've set it to 1. As I mentioned previously, this is all the code that gets executed until the user selects your menu item. Once they do that, the get command string method is called. Not much to this function either, so hopefully you're getting the feel that this is very easy code to write. This function is called to get a string representation of your command that's going to be passed to your invoke downstream. In the implementation here, I'm validating that it is indeed asking for the verb. I'm double checking that it's asking for the menu item that we saved in our back pocket. And if it is, we simply copy the string form of our verb into an out parameter and return. And then invoke command gets called, which is where all the fun stuff happens. So at this point, we're now ready to execute the command. At the beginning of this function, I take and look at the string form of the verb and make sure it is the one that we implement. If you're adding multiple menu items, you can use this to key off of to figure out which implementation to execute. Once we've validated that we're in the right place, we call getSite to get an iData object pointer back to the host. Now getSite simply calls query interface on that IUnknown pointer that we saved in our back pocket. When we get that iData object back, in it is contained data in a special structure that is an array of CEO IDs. A CEO ID is a reference into a database that represents, in this case, a contact, which is what the user had selected when your menu item was chosen. I've written a quick helper function here that will extract that OID from the iData object and hand it back to me so that we can use it downstream in manipulating. Get contact data from OID is where I then leverage that. Get contact data from OID uses the Pocket Outlook object model to take the OID and extract the properties we're interested in, and I fill out this message format structure, which is essentially all of the strings of relevant properties. I'm not going to go into detail of this function right now. I'm going to talk about the Pocket Outlook object model in just a second, and then when I'm done going over that, we'll go into the details of this function. The next thing I do is take this structure, which is a list of strings, basically, and I encode it into a single buffer so that we can send it over the SMS channel. The implementation is just a bunch of stircats lumping the string together as a comma-separated string, so I'm not going to go into the details of this function either. However, one thing it does do is it puts as the first item in our list of properties a special identifier that says, this is my contacts demo, so that when we receive the SMS on the other device and we start looking at the SMS message, we know that this is an SMS message that we're interested in. I follow this with a call to a helper function I've written called send text message, which I'll go into more detail after I explain text messaging or SMS messaging more here in a bit. But it's a simplified function where all you have to do is pass a phone number and the message, and it will send it to you. And that's basically it. At this point, we clean up, and we exit our function. We're done. We've now sent the SMS off to the other device. So we'll flip back to the slides. Now, the Pocket Outlook object model is a COM-based Outlook object model that you can use to manipulate the PIM types on the device: calendar, contacts, and tasks. It's similar to the Outlook object model on the desktop. So those of you who have created solutions using desktop Outlook should find this quite familiar. It can be used to extend applications as we've just seen using menu extensions. And you can also create new applications from scratch. I'm only going to have a couple slides on the Pocket Outlook object model. There's a full session on this at 5:45 today. So if you're interested in going into a lot of the details there, I highly recommend attending that session. Now, this is a hierarchy of the Pocket Outlook object model. And what I'm going to show you how to do today is obtain a pointer to an item at the application level, and then show you how to manipulate it down at the item level. And you don't have to worry about all of the other boxes in between. If you're really interested in the other boxes, be sure to get to that talk I just mentioned a moment ago. So to do this, it's pretty simple. You call co-create instance to create the application object. There's a method called logon you use to initialize the object model. The application object exposes two interesting functions to us today. One is get item from OID, which we're going to use in just a second because we have the OID of the contact we're interested in. And another one is create item. So if you want to create a new item from scratch, you call that. You can then use a series of get and put methods to manipulate the item, and then when you're done, you log off. So let's go and switch back to the editor, and we'll look at our implementation of get contact data from OID. So here you can see the startup of the function. I'm calling co-create instance and asking for an application object. This will get the application object for POOM, and I'm asking for the IP Outlook app interface. And then you call logon to initialize POOM. Pretty straightforward. We call get item from OID to get our contact. The first parameter is the OID that we extracted from the iData object earlier. The P item is an out pointer that will give us a pointer to the contact that we're interested in when we're done here. And then we call a series of get methods to get the actual contact data from the database. And I've highlighted getting the first name and last name here. And we'll page down here and get a handful of properties that I'm going to send across the wire. And when we're done, we simply release the item, and then we log off of POOM and release that. We cleaned up, and we're all done. So sending an SMS message. If you look at the SMS documentation in the SDKs, the functions seem a bit overwhelming. There's a lot of parameters to the methods. There are some big structures that you need to set up. It's really not that hard to do, though. It's more of a, like I said, a lot of parameters to deal with. To do this quickly and easily, you just simply have to open a handle to the SMS engine. You set up a destination phone number structure where there's just a couple of items in it. You set up your message options that are the options you'd like to send the message with. There's a single function with a ton of parameters called the SMS send message that you call, and then you close the SMS engine. So we'll flip over to the editor again, and I'll just show you the implementation I have here. So here you can see that I've called SMS open and told it to use a mode to send a message, because that's what we're going to be sending our contact over the air. Setting up the address structure is pretty easy. We tell the engine that we don't know what kind of number we're going to be getting because it's being passed in as a parameter to us, and then we just simply copy the phone number string over into the structure. We set the options up so that we're sending a class 1 message, and then we simply call SMS send message. We pass PWSC message is our message in the buffer. We pass the size of that, the structures we just filled up, and that's all it takes. Once we return from this function, hopefully our SMS message has been sent over the network, and then we close down the SMS engine by calling SMS close. So now we're done with sending the contact from our source device, and we have to deal with receiving the SMS message on the destination device. The inbox application provides a plug-in chain that you can hook into for SMS. It allows you to pre-process the messages before they actually get displayed to the user. This is done using an interface called iMailRule client. I'm going to go into that in a little more detail in a second. For debugging these, you're going to use the same tools. The registry viewer is useful for making sure that you have your environment set up correctly. The process viewer you need to use to kill the inbox application so that you can be loaded after you make modifications to your mail rule client. And in this case, we did include tmail.exe in the SDK. So you will actually be able to set breakpoints in your mail rule client and step through your code. Now, a mail rule client is a COM object that's invoked by inbox every time an SMS message comes in. You'll have the standard COM registry keys that you'll need to set up. And there's some extra keys that you add in order to let inbox know that you wish to be a mail rule client. Basically, you need to know the transport that you wish to plug into, and that's pretty easy because we only support SMS at this point. You also need to know the class ID of your COM object so that the mail rule or that inbox knows which object to instantiate. In your object, there's a simple interface, iMailRule client. It's essentially a single function to filter your message. There is an initialization function. You just don't do a whole lot in it. So at this point, what I'm going to do is we're going to live on the edge a bit here, and we're going to walk through this and do a live demo of debugging the mail rule client. What I have here are a couple of devices. The one that's turned off has our menu extension loaded on it that we have written. The other device has the mail rule client that we're going to debug. And the first thing I'd like to do is launch contacts over here, and we'll see that all I have is voicemail in my contacts. And before we go to the other device, I'm going to plug in the debugger. Come on. And we'll switch over to our environment. And here I have the process message functions brought up. I've got a breakpoint set already. The first thing I'm going to do is make sure that tmail.exe isn't already running, because if it's already running, it can't load my menu my mail rule client in. So we're going to go to the remote process viewer again. This time we're going to select the device, and we will connect to the device and hunt through the list here and look for tmail.exe. Which I don't see, so I'm just going to shut it down and switch back to the devices real quick. So we'll come to our source device and go into contacts, and we'll see I've already entered my name as a contact. We'll select menu, and then at the bottom is our new menu item, which I will hit 6 to quickly select. Now it takes it just a minute to go through and do this, and it sent our contact successfully, and we'll hit OK. And hopefully by the time we switch back to the debugger here, we will have gone all the way through. Come on, let's go. Oh, I need to start the debugger first. That would help. And hopefully we'll beat the SMS message. Otherwise, I have to kill it again. Okay, I think we may have missed our message. All right, well, I will just walk through the code then. So if I would have, yeah, let's stop the debugger. If I would have remembered to start the debugger on time, we'd be starting at this point. So I'm going to skip over the initialization at the top of the function here. And the first thing that I do in my mail rule client is I call get SMS message text. Get SMS message text is a helper function that will retrieve the SMS message from CE-MAPI using the CE-MAPI APIs and stuff the text itself in the WSZ message parameter. Since I haven't talked about CE-MAPI, I'm not going to dig into the implementation of this function. There's a talk right now that's happening right now on Inbox, and I recommend that you guys watch that on the conference video once the conference video shows up. Once we have the message in our buffer, we call a function called parse message. All this is going to do is take our comma-separated string, build up our structure again so that we'll be able to set our properties in a minute. The other thing that it does is it looked at the beginning of that message to make sure our special identifier was there and that this is actually an SMS message that we were interested in. If it wasn't a message we were interested in, this function would have failed. We would have exited from the function, and then the message would have just passed on to the next item in the chain. Add contacts using POOM. We take that structure that we have and use POOM to add it into contacts. So I'll go ahead and look for the implementation of this. Again, we're creating the application object for POOM so we can manipulate it. We use the logon function to initialize. This time we use the create item method to create a new item from scratch because we're creating a new item on the target machine. The first parameter tells the system what item type that we'd like to correct. In this case, we have it set to contacts because we're adding to contacts. And then we call a series of put functions in order to put the data back into the store. This is analogous to the gets on the other side. So we put all of our properties. Now the interesting thing we do when we're done putting the properties is we have to call the save method, which will commit our properties to the database. And then we follow this with our cleanup code to release the contact, log off of POOM, and then clean up the rest of the function. So let's... So at this point, we're done for the most part. The contact item has been added to the device using POOM. If we were to go into contacts right now, we would see the new item there. The SMS message is still in the store, though, and if the user went to the SMS view inside of Inbox, it would show up. So I call a helper function called delete message to delete it out of the store. Again, this is a helper function. It uses CE-MAPI to delete the item. I'm not going to go into the details here. As we exit the function, we set a couple of out parameters to instruct Inbox how to proceed. The first one is to tell Inbox, hey, we've deleted this message out from underneath you in the store. Don't worry about it anymore. The second one is to tell Inbox not to continue with the plugin chain. So for instance, had we not deleted it, we could allow the message to be processed downstream even further. And at this point, had I not screwed this up, we'd look at the device and seen contact on the actual device. So let's switch back to the... Oops, that was the demo we just did. So there's a ton of resources available to you as you're going through and creating your great smartphone applications. The first is the Windows Mobile Developer Portal. I've got the URL for this listed at the bottom of the page. It gives you access to the latest technical articles and access to our public news groups for some help. We also have the Windows Mobile Solution Partner Program, which you all can join. There's a session on this on Friday that I recommend you attend. And the Mobile to Market program. There was a lot of discussion about this in the keynote speech this morning. I'm going to loop back here again and go back to the application security model. The Mobile to Market program helps you get your applications out there. It's critical that you understand the application security model, and Mobile to Market is a great resource for you here. Some other sessions that you guys should check out are the session on Friday at 2 p.m. on the smartphone security model. They're going to go into much more detail about it than I presented today. This afternoon, there's a session on the Pocket Outlook object model, and that's at 5:45. We'll go into great detail, that diagram that I showed. And then, as I mentioned a little earlier, there's a session on messaging right now, unfortunately. So you should catch that one on the conference video. So when you're done here, be sure to go check out the Windows mobile booth. There's tons of resources there. There's people to talk to. You can pick up the Mobile Developer Resource Kit. As you leave the room, be sure to fill out your evaluation form so you're registered in the MPX 200 giveaway. And I'd like to thank you all for coming. I hope you have a great conference. And I'll take any questions at this point, and I'll bring up my appendix slide for those of you who are interested in taking those down.